we're going to look at how to solve systems of equations using your TI calculator. And so let's start with a system. Let's say we have x plus 2y equals -3 and 3x minus 5y equals 13. So what we're going to do is we're going to change this into a matrix. This matrix is going to look like 1, 2, -3, 3, -5, 13. Okay, so on the, I made a little division here. Sometimes you'll see they'll do like little dots, or they'll put like a little, just a line there, whatever, to kind of show you where the coefficient matrix and the constant matrix will be joined together. That's not going to do anything mathematically. It's just decorative, so we know. And what we're going to do is we're going to put this in what's called RREF, reduced row echelon form. And that's what we're going to use the calculator for. So we're going to go over to our calculator, we're going to turn it on. Now this is an older model, so it actually has a matrix button. Most calculators you're going to see 83s and 84s, the matrix is going to be the second function of x to the -1. So that's how you're going to hit second, x to the -1, and that's how you'll get in your matrix menu. Mine's a little older, so I'm going to hit it here, and I'm going to go over to edit, and I'm going to select one of these in. So I'm just going to put it in A, but I could go down and pick a different one if I wanted to. I'm going to select that, and I'm going to hit enter. This size is a 2 by 3, so 2, enter, 3, enter. And then I'm going to put in the numbers. 1, 2, -3. And again, notice that line, it's just not in here. It's not an issue. Just ignore it for now. I'm going to put those in. Then what I'm going to have to do is I'm going to have to quit back to my main calculation screen. So I'm going to hit second, quit. And I'm going to go back into my matrix menu. So you're going to hit probably second, x to the -1. I'm going to hit my matrix button. I'm going to go over to math. I'm going to go down until I find this RREF, reduced row echelon form. Don't use REF, that's row echelon form. Use reduced row echelon form. Second matrix, and under names, that's where you're going to select the matrix you stored it in. And I'm going to hit enter. And so what this is telling me over here is I have 1, 0, 1, 0, 1, -2. And so this says x equals 1, y equals -2, writing that answer in an ordered pair, 1, -2, there's my solution. And I can do that with larger matrices. Let's say I had x minus 2z equals -8, y plus 5z equals 16, and 2x plus 4y equals 0. And notice, I'm missing some spots here. That's okay. I'm going to put this in as a matrix, and where those missing spots are, I'm just going to put a 0. -2, -8, 0, y has a coefficient of 1, 5, 16, 2, 4, 0, 0. And again, remember there's a separator from the coefficients to that. Again, that doesn't do anything mathematically. If you don't want to write it down, that's fine. And we're going to put this in our calculator. So again, I'm going to go over here to, you'll probably hit second matrix. I'm going to hit my button. I'm going to go in here. So let's say I want to pick a different one. I'm going to put this under B. And so I'm going to go down and hit enter. And this is a 3 by 4. And I'm just going to put these numbers in. I just hit enter each time, and it just moves me across the rows. And then when I get to the end of a row, it'll start me on the next one. That's usually the easiest way. You can use your arrow keys if you make a mistake to go back and correct it. That's fine. But when you're just typing them in, it's usually easier just to hit enter each time. All right, so second, quit. Go back to my normal screen. And now I have to do some matrix math, so I'm going to go to second matrix, go over to matrix math, go down to that RREF, not the REF, but RREF, reduced row echelon form, select it, go to second matrix, select your name, and remember we put this under B, and we'll do that. And so we got an answer, looks like 1, 0, 0, -2, 0, 1, 0, 1, and 0, 0, 1, 3. And again, that's the coefficients of the variables. So x equals -2, 1y equals 1, and 1z equals 3. Putting this in as an ordered triple, there's our solution. All right. Some special situations that can happen. So things don't always work out nice like they should. So let's look at a couple of special cases of things that will happen. I'll just look at the two equation, two variable. So let's say I have this system. And I'm thinking, okay, I'm going to do my thing, put this in as a matrix. No problem. So second matrix, what you're going to do, go over to edit. I'm just going to put this in as A, still 2 by 3, 4, -6, 2, 6, -9, 1. Second, quit. Go over in your matrix menu, go to math, reduce row echelon form, second matrix, and then whichever matrix you stored it under. And let me just real quick mention, if you think you might get fractions, hit your normal math button, change to a fraction. And if there are fractions, it'll display it as fractions instead of decimals. So, hey, all right, I got a fraction here. That's nice. It would have said -1.5 instead, but now I have a fraction. So I got 1, -3/2, 0, 0, 0, 1. So remember this left-hand side is the coefficient. So I have x minus 3/2 y equals 0. In the second equation, my coefficient of x is 0, my coefficient of y is 0. So this side is 0 equals 1, except 0 doesn't equal 1. So that doesn't make sense. So this means the system is what we call inconsistent, or you can say there's no solution. These lines do not intersect. Basically, they're parallel lines in this case. And that can show up when you're talking about 3 letters and 3 variables. All right, let's look at another special case that could happen. Kind of similar equation, 4x minus 6y equals 2, 6x minus 9y equals 3. So put that in there, 4, -6, 2, 6, -9, 3. Put that in. So second matrix. Go over to edit. I'm just going to use A here. 2, 3, and you notice I can just use my arrow keys. So this is very similar. This is a 2. The first equation is the same. What about the second equation? 6, -9, 3. Okay, so I'm going to change that. Second, quit. Second matrix, math, reduce row echelon form. Second matrix of this one. Again, maybe there's a fraction. I'll add that on there. And there are fractions. Great. Here. Okay, so this is 1, -3/2, 1/2, 0, 0, 0. So x minus 3/2 y equals 1/2. And 0 equals 0. Well, 0 does equal 0. In fact, it always equals 0. This is what we say the system is dependent. What that means is there's an infinite number of solutions. But they're not random. There's a pattern to them. And so we want to do the pattern. Now, a lot of times what you'll do is, since we're used to doing lines, you'll solve for y, but how I have this equation written, it's actually smarter to just go ahead and solve for x. And so add that 3/2 y to the other side, and you get x equals 3/2 y plus 1/2. You can write your answer as your x value is 3/2 y plus 1/2, comma, your y value is y. Now, sometimes people will change these letters, and they'll make it something like 3/2 a plus 1/2 a, and then a could be any real number. You know, I usually don't require you do that, but you know, that is something you could do. Okay, let me give one more kind of special case here. So let's say I have 4x minus 3y equals 1. Oops, sorry, that's the wrong problem. Another wrong one. Hopefully this doesn't mess it up. All right, so let's try this again. 2x, that's something you want to be careful when you're copying. Don't shift lines and copy down the wrong problem. Okay, so I'm going to put this in here. 2, -3, 1, 4, 5, 13, 1, -4, -2. Notice this is a 3 by 3 matrix, so second matrix. I'm going to put in there 3 by 3, 2, -3. And make sure when you're using these TI calculators, you do use the negative button and not the minus button. They're very touchy about that. Casios, I find, are a lot more forgiving than this, but these are not. Okay, so second quit, second matrix, reduce row. And then sometimes it's faster just to push up instead of down to get there. Second matrix, select your matrix here, and you get this as an answer. Say, okay, I'm going to write this answer down. 1, 0, 2, 0, 1, 1, 0, 0, 0. Okay, so if I translate this, I get x equals 2, y equals 1, and 0 equals 0. Now, from that last example, you might think this means, oh, the system's dependent. But look at the original problem. We had 2 variables, x and y. We had 3 equations. So we had too much information. That's all that this last line is saying is, oh, you have too much information. You need all 3 of these. And that didn't cause, you know, the danger of having too many equations is they may not all line up at the same spot. And you might get a 0 equals 1 situation, which would be inconsistent. You know, once you put that third equation in, you might run into a bad situation. So that's why you don't usually try to use more than the number of equations as variables. But this isn't saying the system is dependent. It's just saying that all 3 are working together and they're all intersecting at this 2, 1 location. So watch out for that. 0 equals 0 does not always mean dependent, only if you don't have enough information to find the actual solution. So this one, we only had 1 equation with information, and then 0 equals 0. That's meaning these equations are basically redundant. They're the same equation. Only one of them gave you valuable information. So that's how you solve systems of equation using your calculator.